Hello, today we're going to talk about Hess's law. So Hess's law states essentially that the enthalpy, or the heat for a reaction, is going to be constant whether it happens in one step or in multiple steps. So essentially, if you remember back in kinetics, we looked at some energy profile diagrams. So you could have just one single step, or you could have multiple steps, like that. And sometimes we drew it on the same graph to look like this. And so depending on the reaction, you might use a catalyst to make it happen in multiple steps, give it an alternate pathway to make lower activation energy happens faster. But the net change in energy for that particular reaction is going to be the same whether it happens in a single elementary step or in multiple steps. And that's Hess's law. So there's a couple of rules when we're solving Hess's law problems. It's almost like a puzzle. The reactions must add up to the target reaction. So you'll be given multiple different possible reactions. Typically you will use all of them. Occasionally I've seen them throw in like a red herring reaction, but for the most part you'll use all of them. But you have to make all of the individual steps add up to the target reaction. So you might have to reverse a given reaction. So if you flip it around, make the reactants products flip sides, then you will change the sign for delta H. So if the forward reaction is endothermic, the reverse reaction will be exothermic. So when you flip it around, you'll make it the opposite sign. Another thing that you could do is if you need a different number of reactants or products, you can multiply reactions, but you have to multiply the whole reaction, and whatever you multiply the reaction by, you would also multiply that into the heat as well. So let's look at some examples to make this make a little bit more sense. Okay, so here's the Hess's law problem that uses fake reactants and products. We're just using A, B, C, D, E. But it's a good, just a little example for us to look at. Now our goal reaction or target reaction is this one. A plus 2B yields C plus 2D. Right? Now they give us some multiple steps that we could use to make that target reaction. The first one is 4B plus 3E yields 2C, and they give us delta H, it's endothermic 124. A second possible step there is 2D plus 3 halves E yields A. So this could be, maybe it's a formation reaction. Typically when we see those fractions, you'll see that it's a formation reaction. But anyway, you're going to have the delta H for this one's exothermic is negative 15. All right, so what I do is I go through and I always start with the first reaction and see what needs to change to get it to be more similar to the target. So I don't see A in this reaction, but B is there. Now it's on the correct side. They're both on the reactant side, so I don't need to flip it, but I have the wrong number. So I need to multiply this reaction by 1/2. And whenever I do the reaction, I have to do the heat. So I'm going to rewrite it. So if I multiply everything by 1/2 there, it would be 2B plus 3 halves E yields C. And then for delta H, if I divide that by 2, it's 62. Once I've done something to one of the steps, once I've changed it, I want to cross it out so I know not to use that heat. All right, so now my B's match, okay? And if you look, also the C's are matching now. I have one C on the product side, 2 B's on the reactant side. So that's good. Now let's look at the other possible step there. We have 2D. Oh, but it's on the wrong side. Okay, the correct number, but wrong side. So I can flip that equation around. Let's make the products on the reactant side and the reactants on the product side. And when I flip it, the delta H changes signs. Now it's positive 15. Once I've done something to a reaction, I want to cross it out. And then the last thing you want to do is you're going to add everything up. Okay. So all of the reactants on the left, 2B plus 3 halves E plus A, yields C plus 2D plus 3 halves E. And then anything that's the same on the products and the reactant side will cancel out. Spectator ion or it could be, in this case, it's a catalyst, because it's a reactant, not a product. Doesn't matter. But anything that's the same on both sides cancels out. And you also want to add up the heats. So the delta H will be 77. And then just double check to make sure that your final reaction is the same as the reaction that you were looking for. A and 2B on the reactant side, C and 2D on the product side. So we're good. And you're done. Okay, here's another example using some real reactants and products. In this case, they give us 3 possible steps, and the goal reactions at the bottom. We're looking for 3NO2, H2O, HNO3, and NO. Okay, so let's look at this reaction here. Okay, so I see I have NO, but it's on the wrong side of the reaction. But wait a minute, there's also an NO in this step. So I'm going to just wait on NO, and we'll not look at NO yet. Oxygen is not in my final reaction, so I don't want to look at that, but we have 2NO2, and I don't see NO2 in any of the other steps. It's 3NO2 in my goal reaction, so it's on the wrong side, and it's the wrong number. So I need to flip it and multiply by 3/2. So let's go ahead and do that. I'm going to flip it and multiply by 3/2. So 3NO2 yields 3NO plus 3/2 O2. And my delta H times the negative 3/2, because I flipped it, so it changes sign, so negative, times 3/2, because that's what I did with the reaction. And I get 174 for that one. Okay, so that cancels out. All right, now look at the next one. So I have NO2s on the correct side. Next thing, N2 is not in my overall. O2 is not in my overall, but H2O is. Water is on the side, and I don't see water in any of the other reactions. So it's on the correct side, but it's the wrong number. So I need to multiply this second reaction by 1/2. So I'll have just N2 plus 5/2 O2 plus H2O yields 2HNO3. And I'll multiply the heat by 1/2 as well, negative 128. Delta H. So I want to cross this one out because I've used it. Alrighty, so now I have the water's in the correct side, correct amount. The NO2 is on the correct side, and then my HNO3 is now on the correct side. But NO is the wrong number. I have 3 NOs on the product side. So let's look at this last one. Let's see. So N2 plus O2. So I need to go ahead and flip this reaction around. So that way the N2 will cancel because it's not in my goal. Some of the O2s are going to cancel out. And the NO, some of those will cancel out if it's on the reactant side. So let's flip that reaction around. And I have 2NO yields N2 plus O2. And then my delta H will change to negative 183. Right. Now I need to see and make sure everything that needs to cancel cancels. You can go ahead and, if you want to, you can write all of the reactants on one side and all the products on the other side and then cancel, or you can cancel and then add it together. Either way is fine. Okay, so it looks like the 2 NOs will cancel and leave just 1 on the product side. The N2 cancels. And then I have 3/2 O2 and 1 O2, so that makes 5/2 O2, which cancels out with this 5/2 O2. So the oxygens cancel, which is good. So now I'm left with my 3NO2, my 1 water, my 2HNO3, and my NO. So everything adds up perfectly. That means now I can add up all of my heats and define the overall enthalpy for the reaction. And I got negative 137. Negative 137 kilojoules. And kilojoules are kilojoules per mole reaction. And so that would be about as complicated as the Hess's law reactions get. But you just need to go step by step, figure it out, try to make the puzzle work out.